Hey everybody, this is a bit of a milestone video. We're over 100,000, so I want to say thank you to everybody that's visiting, that's reading our pages. It's great news. This is fantastic. We're leaps and bounds ahead. We've got some awesome technology. Some of this is restricted access. Unfortunately, the people that have been doing this have wanted to do this in the quiet to iron out kinks and stuff like that. So some of this is restricted access, but all of this here is what we've been working on and what we have to share. Some of it coming soon. So 100,000, that's awesome. Thank you everybody. We're making huge milestones. This is for humanity. We all work for the same goals, same reasons. We're all doing this for our future, for our children's future. What we're doing is trying to give everybody power, electricity, electrical energy at minimal cost. Okay, so there is a way to do it. Conservation of energy law still stands. We're not breaking any laws of science the same way as the electrical generator doesn't break any laws of science. We're just going about it a different way. Okay, so we're thinking outside the box and we're doing things that people have not thought about before. Okay, now this video is going to be a little bit of an eye-opener for some people. It will be boring as anything for other people, so I do apologize for that. But this video is going to be about moving magnetic fields and what a moving magnetic field can do. Okay, I've got to apologize. I'm using a couple of videos and images off the internet. This one's one of the better ones that I could find. It's a little bit blurry, however. Now, what I have seen in my experience is electrical currents are thought of in a very magical, mysterious way. Okay, electrical currents are thought of as you have to put something in to get these electrical currents out. Conservation of energy law states that, and that's just how it is. What science and what people haven't thought about is that any time a magnetic field is moving in the proximity of a copper conductor, the movement of the magnetic flux itself generates these currents. Now, the old video that was seen on the website 100 times, I use it all the time to sort of show a point, and I'll show that in a minute. But the old video of dropping a magnet down a copper tube generates electricity, and it's confused. Science deliberately confuses it. Science calls these currents eddy currents. Each eddy current has its own magnetic field. Now, in these magnetic fields, the magnetic fields oppose the other magnetic field that's falling down. So there's always an opposition. Always an opposition. And if you look close enough, you'll be able to see that there's a opposition. So the arrow here on this green circle, which is a little bit hard to see, but you can see it is pointing in this direction. Okay, this arrow over here is pointing in this direction. So the red magnetic field here, red magnetic field line, is being opposed by the green magnetic field line over here. Okay, the gold one is the eddy current. Okay, eddy current being generated in the copper conductor by the movement of magnetic flux. Okay, so as the magnet drops through the copper tube, the change in time of these magnetic field lines, which is critical, people need to think about this. Anytime there's a change in time of magnetic field lines in the proximity of a copper conductor, okay, and when I say a change in time of magnetic field, it doesn't have to be your primary coil. It can be your secondary coil. Your secondary coil is a magnetic field changing in time as long as that secondary coil is loaded. Okay, if the secondary coil is loaded, it's carrying a current. A current is, by its very definition, moving charges, which creates a magnetic field. So one is the same as the other, basically. They're both the same. So what I want to sort of point out here is that these eddy currents, they call them eddy currents, but it's completely not a very good term, because eddy currents are exactly the same as any current in a copper wire in a generator. They're the same thing. So it's exactly the same. They're not different. You could call the current in a generator an eddy current as well if you wanted to. The reason that they do call them an eddy current is because they swirl in the same proximity. They're not guided, they're not directed. You got to think that if this copper tube was a copper coil, then there'd be turns around here. The insulation on the wire would be guiding the current, would be directing the current in a specific direction. Okay, so again, if we had a coil, if this copper tube was replaced by a coil, and we had the ends tied on the coil, then we would get the same effect. The exact same effect would happen. The direction of the currents would be different because the turns themselves would be perpendicular rather than circular. Okay, so we're essentially guiding the currents. It's no longer an eddy current because the current has direction and magnitude. It's not an eddy. It's not circling in on itself. So why is there a current there? There is a current because the copper conductor itself holds charge. The copper conductor is conductive. The copper conductor has charged particles in it, electrons, protons. You could also say other things as well, ions, which is supposed to be a hole where an electron is left, can have charge as well apparently. So anything that has charge has a mass. It has to have a mass, and therefore it has to also have, because it's got charge, has to have a magnetic field. So a magnetic field, an external magnetic field to a charged particle inside the copper conductor here, will influence the charge, and that's why it has to be moving. So basically, anytime there's a charge, anytime there's a magnetic field, if the magnetic field changes in proximity of the charge, then the charge will change its direction, and therefore it will have a movement to it. So as soon as the charge moves, then obviously that movement will create an eddy current in here. Now again, remember that if it's a coil, we have turns which are perpendicular to the tube going down. Okay, tube going down this way, turns being perpendicular that way. So obviously from an eddy current, the eddy current would turn into a directional current having magnitude and direction. So this is the thing I'm trying to get across in this video. People think of currents as magical things that you have to put into the machine. You can't get a current out unless you put the current in. Now it's completely not true. Okay, I've asked the question before and no one's really given me an answer. Where does the current come from in an electrical generator? Okay, people say we have to turn the shaft. Well, technically that's not where the current comes from. Why is it not where the current comes from? Because there's no electrical connection between the shaft of a generator and the coils. The coils are completely isolated, insulated from the shaft itself. Okay, normally the shaft might carry a few magnets. Sometimes the shaft itself, on the rotor at least, might have a few coils or magnets. It can have both or one or the other. And the movement, the very movement of the coils or the magnets themselves are what creates this charge. And again, the charge is the same as eddy currents. The currents are exactly the same. It's the changing magnetic field in time in the proximity of the conductor that gets the charges moving in the conductor. When the charges are moving in the conductor, they will become eddy currents, which are circular. They're circular around themselves, unless they have direction. They're given direction, which an insulated wire will do. So what I'm going to do is I'm going to play a quick video now, one that I've been playing for a long time. US military declassified video back in 1954, I think it was. And I want to get everybody to watch this video and try and understand what I'm saying. Okay, now essentially what I'm trying to get across here is that every single piece of charge, every single voltage, every single charge that comes out of a generator in the form of voltage and current, every single piece of charge comes from the copper coil itself. Okay, that's a really it's a very strict definition that people need to understand. The charge comes from the copper coil itself. Okay, so if we were to have a copper coil sit here in front of us, and if we were to instantly pull out all the charge from the copper coil, then essentially it would disintegrate. Okay, so what we're doing over time is we're pulling the charge out of the copper coil, okay, and we're doing that by moving magnetic fields. So the moving magnetic field structures the charge, and it pushes the charge down the wire. Okay, and that's what the moving magnetic field does. I'm going to play you the video now.
This represents a neutral atom in electrical balance. Earlier, we saw how an outside force can break an electron away from an atom and start an electron chain reaction, an electric current flow. One way to provide that outside force is by use of a magnet. It was proved with iron filings that a magnet has magnetic lines of force which connect its poles. For simplicity, let's consider the effect of this magnetic field on a single electrically neutral atom. Now, we move the magnet so that the magnetic field strikes the atom, supplying energy which forces an electron to leave its atom and become a free electron. The result is a sort of electron chain reaction. In a substance such as a length of wire, electrons are normally moving in all directions. But when a magnetic field is passed through the wire, several electrons are forced from their atoms and move in one direction. Now, in studying electricity, we're mainly interested in the movement of free electrons. So, for convenience, we'll look only at the action of electrons in the wire. When the magnetic field sweeps down across the wire, electrons move in one direction. When the magnetic field sweeps up across the wire, the electrons move in the opposite direction. This movement of electrons in either direction constitutes an electric current flow. If we move the magnetic field more slowly across the wire, fewer electrons are affected in a given period of time, and the electric current flow is decreased. And when we stop moving the magnetic field, the electric current flow stops, and the electrons again move in all directions. If this wire is connected to a meter, we find there is no electric current flow. When the magnetic field is moved down, this meter shows current flow in one direction. If the magnetic field is moved up, the meter shows current flow in the opposite direction. We can change the amount of electric current flow in several ways. Move the magnet faster, more current flows. Use a stronger magnetic field, still more current flows. Now coil the wire so that several turns are in the path of the field. Again, the current flow is increased. Stop moving the magnet, current flow stops.
Okay, so what we've just seen is we've seen that charge, the electrons, any quantum particle, if you like, with a charge on it can be manipulated by a moving magnetic field external to the charge itself. There's a field called spintronics. It used to be called spin flipping. No doubt they'll change the name again, which relies on these very fundamental processes. Spintronics could lead to, in the very near future, breakthroughs in electronics. So our devices will probably be able to store very much more information, be very much faster, be very much more economical electrically to run. So there's huge areas ahead. What we've got to realize is any particle that has a charge, it must have a spin, must have a magnetic field. So every particle that has charge, has spin, has a magnetic field. That means any external electromagnetic field can manipulate that charge, can manipulate that particle, can either move it, spin flip it, or do whatever. Okay, so this is important stuff to sort of realize. Now this is all contained inside the copper wire. Okay, the point of insulation is that the excuse me, the point of insulation, Chris, cut that bit out. The point of insulation, the entire point of insulation, is to make sure that this charge doesn't move across boundaries. Okay, so if we didn't have any insulation on our wire and we wrapped a great big coil, then the big coil would be a dead short, because the charge would just be able to go from one terminal straight to the other and completely bypass the coil itself. Okay, so we've got to realize that by insulating a wire, we are effectively stopping the charge from moving outside the boundary of the copper wire itself. Okay, and again, the coils on the generator are completely isolated from the rest of the generator. The only thing touching them is the changing magnetic field, okay, which moves them down a wire. It's very, very important stuff to realize, very important stuff to think about. Now I just want to show quickly, Floyd Sweet made a very important statement. I'll show that now. Okay, Floyd Sweet wrote lots of documents, all of them of which are up on my website, highiq.org. If you go to the reference page, from there you'll be able to find Floyd Sweet and you'll be able to read the documents from there. This is the space flux coupled alternator. Now I believe from a series of events that this was a rotating machine, effectively a generator, that was just before the vacuum triode amplifier, but used the same principles. Now I believe by reading this and reading other documents on Floyd Sweet that you can get a pretty good idea on what he was doing. It's not hard. He was a true scientist. He knew many science terms, techniques, all that sort of thing inside out. So what I want to show you is a very brief statement Floyd Sweet made to give you an idea on how he was thinking. Okay, so this here, well, let's read from up here. The feedback loop. Okay, previously mentioned. You will more clearly see how the loop functions at the time you see the physical construction of the stationary armature, or it's supposed to be or stator assembly. Okay, so this is the rotating device. This is an alternator, if you like. The underlying principle, forget Millikan's experiment. Now on that, worth going to look up and see what Millikan's experiment is. Millikan's experiment was, very briefly, you put an oil drop into, if you like, between two charged capacitor plates. You vary the charge on the capacitor and the oil drop will either fall or it will actually go back up. Okay, so it's relying on gravity. And what the Millikan experiment does is it puts a charge on the oil drop. As the oil drop falls, if the charge is high enough, then the oil drop will actually go back up again. Okay, so we're going to have a look at that. Now, this is talking about charge. Okay. has been derived that magnetic effects vary on the square of the current. An important statement, that one. Okay, so worth looking up, worth trying to understand that one. As the load on the machine increases, the volt ampere product increases. The rate of flow of charges increases. Okay, so we're talking about increasing the rate of the flow of the charges. So how would we do that? What would be required to do that? And on that, who else has said similar sort of statements in the past? Quantum mechanics state not all electrons in copper are free to carry charges. I'm not sure about that statement. To be honest, I thought all electrons had charges. Maybe he's talking about the difference between free electrons, which can move, and then not free electrons that are bound to the atom. Okay, because the next statement talks about this. Then it's time to set the wheels in motion to free them from the binding magnetic forces. Okay, so a bound electron to the atom, the bound electron to the atom is not free to move unless something's done to it. Okay, now normally to free electrons it takes force in the form of a pressure, if you like. It can be done, depending on who you speak to, it can be done via external electric fields. I have had debates with people in the past. You've got to think of this from an electromagnetic point of view, because anytime there's a charge that's moving, there's a magnetic field, and vice versa. So it's the chicken or the egg scenario. Some people use the term electric. Well, I say, well, you're missing the magnetic as well. You've got to realize that any moving magnetic field leaves in space behind it, or where it is at least, in its proximity. Any moving magnetic field is an electric field, so you've got to think of that as well. Okay, so once this is done, let's just read that again before we go on, because it is important. So then it's time to set the wheels in motion to free them from the binding magnetic forces. Once this is done, conductivity will improve. So conductivity, okay, you've got to think the copper coil is conductive. The conductivity means the flow of electrons. Okay, conductivity is considered 1 over R, which is the resistance, so it's the inverse of the resistance. So what he's saying here, effectively, by improving the conductivity, he's reducing the resistance. Okay, and he says that in the next bit. And the resistance decrease, as we're dealing with only with electrons. Copper will not change to another metal's atoms, which are mostly empty space, would have many electrons to spare anyway. So that's the statement I wanted to show you in the context of this bit here. Now, to free enough electrons to effect conversion would require magnetic forces approaching infinity. Now this is a very important statement as well, okay, because what he's saying is he's sort of saying that that the magnetic field needs to be sort of approaching infinity to free enough electrons. Now we've sort of proved with some of our experiments that that's not entirely true, that under certain circumstances the machine itself creates its own magnetic fields by the feedback loop. Okay, so effectively you've got to think of this machine as a positive feedback and also a feed forward machine. So under the right circumstances, when these machines are running properly, the very action of drawing a current allows you to draw more current. So it's a positive feedback. So by drawing a current in the first place increases the machine's internal magnetic fields, which change in time, which therefore, if it's all set up correctly, can therefore increase the amount of electrons that you can draw because the internal magnetic fields increase. So you can increase the magnetic fields by increasing the load, which decreases the resistance. So the more current that the machine is using, the higher the magnetic fields will be. Now, in saying that, when you're starting off, okay, when you're just learning this sort of thing, you want to stick with, you really do, and this is really important, you want to stick with a very small load, because you want to be able to see these things going on. If you go with a load with, you know, for example, you'll see most of my experiments use a 12 volt, 300 milliampere globe as the resistive load. Okay. Now, if you were to use, say, a halogen light, and you didn't really quite know what you were doing, then chances are pretty good that your magnetic fields would not show you the right situations in the machine, simply because the load's too much. You're drawing down, you're sort of bringing the machine's internal impedance so far down that it can't really do its job. It's a bit hard to explain, but you've got to get your load right so that you can see what's going on. And then when you start improving the machine, then after that you can sort of play around with the loads. So I recommend just start with just a small load, something you can see a little bit of light to start with, and then you can apply these sort of techniques here. Everything that Floyd Sweet has written in here, everything is true. Everything is true. There's nothing in here that I've found that is not true or misleading. But in saying that, it depends on how you come to the conclusion. You know, what conclusions you reach when you're reading it. You've got to read this from a point of view of Floyd Sweet is thinking about voltage, and he's thinking about current. He's thinking about getting the voltage up, and he always said all along 120 volts was his goal. Right from the early days, he said that he wanted to have 120 volts at 60 hertz was his goal in some of his earlier papers, and obviously to draw as much current as possible. Now this is really important stuff, so you've got to think voltage and current. Okay, what he's talking about here is getting the current moving, getting electrons free from the copper. Okay, so freeing electrons from the copper atoms, which we've just been through, and getting them to move. Now the insulation on the wire will direct them. Okay, all you've got to do is get the magnetic fields moving in proximity of that copper conductor. Okay, the feedback loop, if you think about this long enough, if you think about a feedback loop, so magnetic fields pumping current, changing in time, it makes more and more and more sense the more you think about it. It is really important stuff. Okay, so remembering all charge inside the copper wire has a polarity. Okay, so it has a spin direction, it has a magnetic field associated. It's got charge associated with it. External magnetic fields, external, in this case, external radio waves. These are supposed to show you that there's an external radio wave coming in here at 90 degrees to the magnetic fields, which makes the electron or proton, depending on what you're using, what you're focusing on, to make it spin flip. Okay, so where does the energy come from? Well, for a long time now, we have all known about Einstein and the EMC squared equation. E equals mc squared. So E being energy, M being mass, C being the speed of light. Mass being matter. Matter consisting of quantum particles, from atoms down to electrons, protons, neutrons, all of them, ions, quarks, muons, the whole lot. Okay, so anything at a quantum level that carries charge, again the charge having other properties as well. So any charged particle has mass, has a magnetic field, and has a charge. Okay, the three of them have to go together. It's part and parcel, the whole thing. So Einstein's mass energy equivalence, you can read all about it here. Even Floyd Sweet talks about it. I'll bring up a few quotes and let's have a bit of a look at that. And here you go. Here's one. This is in the document Nothing is Something, one of Floyd Sweet's most important documents, as postulated by Einstein in his famous E equals mc squared equation. That one there, excuse me. Energy is a kind of matter. Okay, so energy is a kind of matter. Now, if you sort of sit and I mean, reading is a thing that in my life I've sort of gone through different stages of reading. And this might sound a bit stupid for most people, but sometimes you can read something and you can think you understand it, but then when you stop and you step back from it and you sort of think, well, energy is a kind of matter. Now, for some people that would just breeze by, and for some people it would just make no sense and they'd just read on. But energy is a kind of matter. Okay, this is coming from Floyd Sweet's own hand. Okay, Floyd Sweet is telling you that matter, okay, the copper wire, the conductor, the copper conducting wire is energy. Okay, that is energy. It's the same thing. So where does all of the world's energy come from? Is from the quantum field. Okay, every single piece of energy comes from the quantum field. We are essentially moving electrons, protons, anything with charge. We are moving anything we possibly can under various different circumstances. I mean, for example, NMR. If you go to hospital and you get if you go into the big NMR scanners and you get a body scan, how does it work? It works on magnetic fields. It works on magnetic fields pulsing your internal body's charge. So anything in your body, being electrons, protons, anything that'll move because of the magnetic fields. Magnetic fields are designed to move all your small, tiny protons, electrons, everything else in your body at such a frequency that it can be recorded, so that they can image your body. Okay, so it's magnetic imaging, magnetic resonance imaging technology, MRI. So we have to think about this in a more clear manner. Okay, so any piece of matter, okay, Floyd Sweet tells you straight off the bat, any piece of matter is a kind of energy. Okay, it's the same thing. Matter, energy, energy, matter, same thing. Okay, compressed at the speed of light. Okay, c is the speed of light and it's compressed by 2. So energy is matter. Floyd Sweet told us that. Okay, we've got to, as a population, as a species, we have got to start thinking of things as they are. Okay, we've got to get rid of this magic hoo-ha that we seem to have grasped somehow. I don't know how. It's not science. There's no science in magic. Okay, if it's magic, it's because science hasn't yet understood it. Okay, again, that was Arthur C. Clarke that told us that. So I urge everybody out there that's watching these videos, it is as simple as a conductor and magnetic fields. You're going to need at least 2 conductors to make this work. You're going to need to make the magnetic fields change in time. The rate at which the magnetic fields change in time will determine your voltage, and the opposition of magnetic fields is what pumps your current. Okay, if you can sit and if you can understand those 3 things that I've just given you there, and if you can put them together in the way that I've just said, then you will eventually build yourself an above unity machine. Energy comes from matter. Okay, Floyd Sweet told us that. Einstein's equations tell us that. It's all through science. Okay, it's everywhere. Einstein's mass energy equivalence, the mass energy equivalence is E equals mc squared, and it's everywhere. Every person that studied any science knows about it. It's not magic. Okay, there's nothing magical about it. Any electrical generator in the world could go over unity if the secondary coil, or if the generating coil, you've got to think of the secondary coil as a secondary coil because it's the secondary source of changing current. Okay, now any change in current is the same as a changing magnetic field. Okay, and in a generator, there's the coil that generates the current. The current opposes according to Lenz's law. Lenz's law predicts a voltage in the opposite polarity as what the source voltage would be. Okay, so if we were to look at a transformer very quickly, okay, good old Wikipedia. Alright, so our primary coil over here, secondary coil over here. This is Wikipedia's basic illustration of a transformer. Primary, if we apply a positive voltage over here, negative voltage over here, the conventional current, indicated by the arrow there, will follow through from the positive to the negative. Now we know that's not the case, but everybody still uses today conventional current, so I use conventional current as well. Okay, so you can apply the right hand grip rule to that, and if your fingers were to curl around through there and curl around like that, then your thumb would point in the arrow in the direction of the arrow, the magnetic flux. Okay, so we apply a right hand grip rule to this coil, a positive there, negative there, conventional current having the flow from positive to negative, okay, and the secondary coil over here would be opposite. Okay, so over here you've got to think of this as in reverse. This is a generated current, a generated EMF, and when loaded the current will flow. Okay, current will flow the same direction. Okay, so positive to negative. Now if you sit and think about this, you'll see that the coil's back to front. Okay, so if you would apply the right hand grip rule to this coil and around there, okay, this coil is back to front. Alright, so in this case, if we would apply the right hand grip rule, our fingers would curl from this terminal over here around this way, which would give us an arrow that points opposite to the arrow there. Okay, so the induced voltage is in reverse on this coil over here to what this coil is. Alright, now the voltage itself is, well, at least the negative sign in the in Faraday's law of electromagnetic induction. Faraday's law itself predicts the negative, which is Lenz's law. Lenz's law is the negative sign inside Faraday's law of induction. Okay, so when you see the negative sign, that means it's equal and opposite, 180 degrees out of phase. So the voltage, if you were to take the voltage from here to here and the voltage from here to here, it would be 180 degrees out of phase, equal and opposite. And when I say equal, because this is a step down transformer, would have less voltage, so the amplitude would be less, but the wave itself would be equal and opposite. Okay, because voltage is basically a magnitude of amplitude. Okay, now the assumption here that I'm trying to get to comes from when we load the coil, the conventional current will still flow from positive to negative. Okay, so in this situation here, current is flowing in the negative terminal and around that way, okay, and coming out this terminal over here. So even though the polarity up here might seem opposite to this polarity over here, it's still the same if you apply the right hand grip rule, but opposite. Okay, so current flowing from the positive terminal up here out through your load off screen, and then back into the negative terminal over here. Okay, so it creates a magnetic field that's equal in magnitude and opposite to the primary, less losses. Okay, so for turn, the ampere turns is equal on the secondary coil to what it is on the primary coil, less losses. So that's why the primary coil must increase its current through the amplitude of the waveform, being voltage. So current must also increase, and it's also dependent on what sort of load we have over here. So what I'm trying to get to is Lenz's law predicts the negative of the voltage, and then it assumes the current to flow in the same direction. Now most of the time it does. However, in the Mr. Prever experiment, we've shown that that's not always the case. anyway, so we have an assumption that conventional current will flow from positive to negative. So that conventional current would then reflect back on the primary and would reduce the primary's impedance. Okay, you gotta think about why the input current to the primary coil goes up. The input current goes up because the primary coil impedance lowers as you load the secondary coil. Okay, impedance being AC resistance, which is a combination of AC resistance, which is the reactance, and the DC resistance. So that impedance will go down in the primary coil as the secondary coil is loaded. Okay. Now this opposition is what we think of as Lenz's law. Now technically it's not, but that's what we think of. Technically the voltage alone, the difference in voltage, the negative sign in voltage, technically the voltage alone is Lenz's law. But we often confuse that with the reverse MMF, the back EMF or counter EMF in the transformer, which creates a equal and opposite onto the primary. So you've got to think of this coil over here as an equal and opposite magnetic field, separate magnetic field changing in time as the primary pushes the coil through this change. So every single change in time on this coil over here, the magnetic field changing in time from this coil is a magnetic field that we can use as a source to drive a tertiary coil. So if we had a tertiary coil over here somewhere, then the change in time on this coil we could see as a voltage, say on another tertiary coil, which might be down here. Okay, now it's polarity sensitive, as I've just pointed out, so you have to look for the polarity. Okay, because one polarity, it will just be the same as the secondary coil. The other polarity, it'll be the same as the primary coil. Now what do I mean by that? So on a tertiary coil, if one of our polarities is the same as the primary coil, then that tertiary coil must oppose the secondary coil. By opposing the secondary coil, we know, because of experiment, and we can prove that the secondary coil is generating an EMF, and thus the current when the coil is loaded will be equal and opposite to this coil. Okay, so third coil would oppose the secondary but assist the primary. Alright, and I've shown that in some of my videos already, many of my videos actually. Now as time goes on and as you get better at building these devices, what will happen is the tertiary coil, as you load the tertiary coil and as the tertiary coil carries more current, the tertiary coil will actually start to push more current back to your source, back to your power supply, and you can see this on many occasions. We've shown it on our website, aboveunity.com. You can see this as current coming back through your primary, back to your primary source. Okay, so when you get your polarities right in this thing, your input your input from your power supply will push a little bit of current into your primary coil, but then when it's finished, it'll push current back out from your primary coil back out to your power source. Okay, and if you average that out over time, it means that you use a lot less current to do the same work. Alright, it's very, very important to understand. Wastidi has shown that many times on the website, just by changing the polarity of the coil using a couple of diodes. Okay, so this is really important stuff. People are coming, are visiting, are watching our videos. People are starting to understand. This is so simple. It really is extremely simple when you start thinking about it in the right way. Okay, mass, or like Floyd Sweet said, if you think about this the right way, wrong document. If you think about this the right way, mass is a form of energy, and mass or matter. Okay, so if you pick up a copper coil, the charge inside the copper coil is subject to being made to move by an external changing magnetic field, and as soon as you make that charge move inside that coil becomes a battery. Okay, so all energy that we've ever supplied to any light bulb, any heater, any motor, anything like that, all the energy that we've ever supplied to any machine, device, whatever, has all come from the copper atoms, from other atoms as well. I mean, we use aluminium wire. There's various other different types of wire that we've used in the past. But basically any conductive wire that is subjected to a changing magnetic field, if the configuration is right, then we receive the energy being in the form of volts times current, and if there's a phase angle, it's cos theta. That energy is joules per second. Okay, energy is energy, and there's just no arguing with that. And when we start to think about these things right, once we start to gain the correct understanding, and we lose the confusion that science has driven into people's heads, because let's face it, some scientists don't even know where the energy comes from. Look, it's the way you think about it. It really, really is. Once this is thought about in the right way, once we see that the copper conductor itself in any single generator is the source of the charge, source of the voltage, source of everything, but only requires the change of a magnetic field, then what we think of as a generator today will very quickly become obsolete. The reason being is the electrical generator is one form of electromagnetic induction. It just so happens that we've used it for how many 100 years. I mean, Faraday's law of electromagnetic induction was about 178 years or something old now. So look, there's more to learn. Electromagnetic induction is incomplete. We don't fully understand it. There are things about electromagnetic induction that have been hidden from society, and this being one of them. You know, scientists will tell you, well, the energy is converted on the shaft of the generator, and then the energy that you put in is in the form of torque is converted to electrical energy. Well, there's no conversion. I'm sorry, but any generator in the world does not convert torque energy to electrical energy. There is torque in the generator, but there's no conversion. Okay, there is no conversion. You cannot, in an electrical generator, you cannot convert mechanical torque to electrical energy. It can't be done in what we know of today as an electrical generator. Okay, there's no transformation method whatsoever. What there is, and what we do have, is we have a torque on the shaft simply because of Lenz's law. Okay, the source changing magnetic field generates an EMF, which is in reverse. Okay, the reverse of the EMF is Lenz's law, which is the negative sign, 180 degrees equal and opposite. And it just so happens because when we load the coil, that the current itself creates a magnetic field, and the magnetic fields oppose. Okay, if we didn't have opposing magnetic fields, there'd be no back EMF, no back torque. Okay, the generator would spin freely. We'd be able to spin the generator as much as we liked and get as much energy out as we liked if we didn't have the back torque, the back EMF. Okay, that's where the torque comes from. The torque comes from the very fact that there's a magnetic field that is created when the current starts to flow. Okay, we can generate as much voltage as we like and have no current, and the shaft of the generator will spin freely. Okay, it's proven time and time again. I showed that in my 101 videos, electrical energy 101, that you can spin the shaft of the generator freely until you load it. Okay, so technically the way we think about Lenz's law, the way we think about the magnetic fields in the generator, is wrong. It's only partly complete. Okay, we have a changing magnetic field in the generator, which is the generator coil, that works to fight the shaft. Okay, that's where the torque comes from. So technically, science does not understand the electrical generator properly. Every single textbook that you read that explains conventional method of the electrical generator is wrong. Okay, yes, it's wrong. Okay, the torque that is input to the shaft is not a conversion of energy. It's an equal and opposite energy, yes it is. But there is no conversion from torque energy to electrical energy. Okay, it looks that way because science doesn't understand it properly. It's not been properly understood. Okay, so I just want to wrap this video up. I want to thank everybody again, every little red dot on the globe there. Everybody who comes to our website, I hope they leave with much more than when they came. That's our goal. Okay, our goal is to make a change to the world. We want the world to become a better place, and obviously anyone can see that there's a huge drive, a huge push, a very positive push, a very strong push behind what we're doing. We've broken ground like no one else ever has before on the internet. We have machines operational. We're sharing as much as we can, as quickly as we can, fairly as we can with people. You've got to remember there's a lot of newcomers coming in, so those newcomers coming in, it takes a long time to get up to speed for some people, that especially those people that don't have a background in electronics and engineering in general. So we've got to take things slow. For those people that have great experience, honestly, you could come in and if you read through a couple of our pages, you could have something working in, probably no more than an hour. And after an hour, probably have spent no more than $20. It is cheap, it is easy once you understand it, and again, like I've raved about over the last 40 minutes or so in this video, it's basically just a set of conductors configured in a feedback fashion, so that once a magnetic field starts changing, it encourages the change. Okay, so it's a feed-forward feedback mechanism, so that the magnetic field increases when the load increases, which means the load resistance comes down. Okay, now it takes a lot of work, it takes a lot of thought. It's not something that people fresh can come into it easily. There's a learning curve. Okay, there's a curve to the building process. As time goes on, builds get better and better and better and better. And I do say to people, learn as much as you can, as quickly as you can. If you've got time to get on the bench, do an hour of experiments a day, and if you've got a little bit of a background in this, I expect probably within a week you should have something running pretty well. Okay, you might not have 1,000 watts coming out, but hey, you have to be realistic. If you're getting 3 watts excess, then that's a fantastic start. Now, I'd like to point out on that, Fighter and his Romanium ZPM, that's the excess that he was getting, about 3 watts. Okay, this is perfectly achievable. You can get on the bench, you can make these machines work. The information that we've shared in this Builder's Guide to Above Unity Machines, the information in this link will help you to understand, along with this video, and all the other information we're sharing. Just on that, if you can afford a small donation, keep our wheels spinning, keep this information coming to you. Please check out our donate buttons up here. Very much appreciate the donations that people can afford. It does help with what we do, the effort that we're making to make this world a better place. Thank you, everyone, and I'm not religious, but I have to say, God bless you all. The world's in the worst state that we've ever been. The coronavirus is the worst thing we've ever seen. Countries, the world as a whole are in lockdown. People are dying. It's terrible. We just want to make this world a better place for everybody. And to see what's going on is absolutely heartbreaking. So my thoughts out to every family, every person on the planet. Let's all work together to make this world a better place and stop horrible things like this happening. Thank you.